use the this.
Yes, that's what we can use it as a mirror. Disconnect this one. Just one direct external display.
It's not
The thing is, now you should go to A1. Yeah, now
Yes.
it's working.
Prateek, you will have to M1s are not working. I'll use his laptop. Yeah, yeah, it's fine. I'll just it's on Figma anyway, so I'll log in and use laptop. साइन इन गूगल ही किया था. So you have that press thing. Share this with you. Okay, what's your email? You have Figma? इसमें लिंक नहीं शेयर. अच्छा कॉपी लिंक है. ओके send me your email.
Check.
Check, 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 1, 2, 3, check, 1, 2, 3. Okay.
नहीं जरूरत
My two. Yes.
send it.
Oh, it's a PPT. Yes. You can tell your opponent's slides. Okay. You send me
Email.
My file.
You can present it from here also, I think. Just make sure it loads. first
Sorry,
initial
friend.
file will send to
Initial file.
Yeah, Mike 6 also.
ठीक है तो तेरा check कर ले then we'll just so who's doing
Not
the
found.
first I'm logged in with this share कर दे इसमें help कर so who's doing the first one
He's doing the first one.
so your laptop is working fine like yours in the
Yeah.
Windows. Can you just type your email? एक हाथ से टाइप नहीं किया जाता वैसे.
तो यहाँ रख देना.
कुछ एडिट करना पड़ेगा.
promise same with my slides
Can you try refreshing?
Next करना पड़ता है.
That would be a problem. बिल्कुल.
Change कर ले करना.
Yes. Yes, just let me check.
तो change कर ले
हाँ change. Yeah, it could be a problem.
Yes, Mike.
पता है क्या?
Force point and click. Tap click. Yes. It's working. Okay, thank you. Yes.
first I'll do the intro
Okay, you are doing intro first? You are doing intro first, right?
yeah I'm doing just an introduction
Okay.
yeah we'll start in I think in 2 minutes
ठीक है. I'll leave it to you.
yeah
अच्छा बच्चा. I'll sit here only just in case. I'll sit here.
sure
Yeah, it's not connected.
Kumar, I'll call you. Just hold it.
Hi, can you hear me? So, hi. Yeah, thanks everyone for coming. I think it's like several years. I think the last in-person meetup we have is in like early 2020, and then the COVID happened. We thought we'll be back in couple of months, and it took couple of years. Yeah, but finally glad to be back, and good to meet everyone again. And so now that things are getting better, we'll start hosting these events regularly, just like the before pre-pandemic thing. So this is our first event, and I hope everything is going well so far. And yeah, starting from next month, we'll try to do these events regularly. So I think it's very good to meet in person and connect with new people and also learn latest things, right? Uh, yeah, with that, I think thanks for Assembly for you know putting this amazing venue. Uh, yeah, I will invite Vijay to briefly invite about assembly, and then we'll start with our talks. Okay, bye. And we have breaks as well. During the breaks and towards the end, let's connect and let's talk. Vijay.
बस ला ಇದು ಮಿರರ್ ಆಂಬಿಕೆ ಚೆಕ್
Sorry.
ಇಲ್ಲಿದೆ No, just yeah. It's mirroring here. Need to mirror here. It's not coming there. Okay. Hey everyone, welcome to the React Meetup. So Assembly is like hosting this, and then we are happy to welcome you all here. Quickly to give about, I'll just take 5 minutes to explain about Assembly. So Assembly is an employee engagement platform where all your people and work can be in one place. So uh, we do this by workflows. So we have like multiple workflows. Oh, one second. Sorry, one second, we'll make sure the screen's visible.
Just
I hope everyone can see. Yeah. So we do this using workflows. Workflows can be your daily stand-up, one-on-ones, sprint retrospective, and you can also do like rewards and recognition, and also whatever like might be your use case for your work, we can set it up using Assembly. So we have like over 100 templates to choose from, and we also have like a no-code workflow builder using which you can customize these templates and also create your own workflow from scratch. So a couple of like quick examples of these templates. We have like a one-on-one template which is like the most popular in our platform. So using this, you can like make sure you cut down the meeting timings. You also have like more accountability and productivity. So next one is the recognition, wherein like you can recognize your peers in the team, which kind of empowers your teammates and also the team morale. And we also have like celebration boards using which you can like set up like scheduled events where for birthdays and anniversaries. Automatically the platform will send out a post for this. And regarding our tech stack, it's in React with we follow the atomic structure, and then we also use these libraries like React drag and drop, React query, formic, playwright, storybook, pusher, mixpanel, and zoostand. And our backend is in Node, and we follow a domain-driven design (DDD), and so we use Datadog, Datadog, Redis, and MongoDB, Kafka, AWS, and a couple of other libraries. And our team is like 40 people split across US and India, and we are like a remote first team, and also a couple of our people are from like PayPal, Honey, Amazon, ZipRecruiter. One other thing, we are like a Series A funded company. Our investors are from LA mostly. Homebrew, Alpha Edison, and Wonder Ventures are a couple of our investors. And finally, like our customers, like we have like really good customers. Like we have like very high productive engagement for our platform from these customers. We have like a lot more. These are a couple of like notable ones, and some feedback also like. So finally, thanks for coming, and just wanted to like plug assembly so that we also get some visibility. So please do visit our like website. We are open for hiring also. You can use the QR code that we have shared in multiple places and check us out. Okay, thank you.
Thanks, Vijay. So I would like to introduce Prateek. Prateek is from Devfolio, and he'll be talking about future of rendering in React.
Hello, am I audible? Yeah. Okay. So hi, I'm Prateek. I work as a front-end engineer at Devfolio, and today I'll be talking about the future of rendering in React. So, I mean, building for web has like never been more powerful in 2022, and with React, whether like many people like it or not, has only been growing or rather been accelerating in growth. With like React right now, last I checked, it had like 14 million weekly downloads on npm, which I know is not an exact measure of popularity, but it also has like 3 million plus weekly active users for its Chrome DevTools extensions. And I believe like there hasn't been a better time to getting started in React. So in this talk, we'll be discussing about the rendering patterns that exist currently in React, the problems that they have, and what are the new rendering patterns that the React team introduced with React 18, and what does the future of rendering look like in React. So right now, like mainly the way we render React apps is like via client-side rendering, server-side rendering, and other meta frameworks like Next.js offers static site generation and incremental static regeneration. So these are the main rendering techniques that we use right now, and then we also have we'll look into all of these, and then we'll also look into the patterns of the future, which are streaming server-side rendering and React server components. Okay, so before we get started with the rendering patterns, let's first discuss about like some of the terminology that I'll be using throughout this talk. So these are the web vitals that that are used to measure the performance of a page. Firstly, we have time to first byte, which is the time it takes for the browser to receive the first byte. Then the first paint is when the first any pixel becomes visible to the user. first contentful paint is the time it takes for the first piece of content to be visible for the user, and largest contentful paint is the time for the main content of the page to be loaded. Like you can consider it as the perceived loading time when the whole app is visible to the user, and time to interactive is when the users can start interacting with the app and the app responds reliably to user input. Okay, so first we'll start with client-side rendering. Client-side rendering has been like the most popular or the default way for rendering React apps with Create React App before like frameworks like Next.js and Remix kicked in. So with client-side rendering, you basically just get a bare bones HTML from the server, and the page which contains the JavaScript, CSS, etc. tags, and you download the relevant JavaScript and then render the DOM via JavaScript on the page itself, and all the logic for routing, templating, etc. are data fetching are done on the browser itself. Okay, so we'll look at an example. Like I've created some sort of illustration on how it works. So consider like this is our app. This is the app.jsx file, and we use React DOM.render to render it in the browser. So once on page load, the browser just gets a simple index.html, and it has nothing. It has the div root thing which React uses to render the DOM, and it has all the meta tags or your CSS and JavaScript, etc. Okay, once the browser passes the HTML, it starts downloading the JavaScript. While the JavaScript is getting downloaded, the users just see a blank page, which is like not good, but that's how client-side rendering works. And once the JavaScript is downloaded, we then render the app. Once the app is rendered, then we have our first contentful paint, and then time to interactive sometimes after that. So even when we have the first contentful paint, most real-world React applications would need to fetch some data to like display it to the user. So we have to make those API calls on the browser to display the data to the user. So we fetch the data from the API, and then only then we have the largest contentful paint, so the user can fully interact with the app. So this is how the network graph looks like. Like we have a pretty fast time to first byte because it's just a static index.html that the server needs to serve, and then we have the first paint when the browser passes the initial HTML, but the user keeps seeing a blank screen until the JavaScript is downloaded and the app is rendered, and the React code is downloaded, code is downloaded, and the browser executes the JavaScript. Then we get the first contentful paint and time to interactive after that, and after fetching the data we get the largest contentful paint. So what are the benefits of client-side rendering? So one of the most easiest benefit is that it's comprised of like mostly static files, so that it can be easily served via Netlify or any static server, and it can be easily served via CDN. And another cool thing is like it allows us to have like navigation without full page reload, so you can do transitions while navigation, so that all stuff is where can be easily done by client-side rendering. And also it has like a fast time to first byte, which allows the browser to start loading relevant assets like fonts and CSS and JavaScript, etc. immediately. And regarding the cons, so the number one is performance. The users need to download all the JavaScript before they can see anything. And next is SEO. Although web crawlers can now pass client-side rendering, but they might not wait long enough for the client-side waterfalls to finish, and might like do an incomplete crawling, or like, which is not good. And data fetching also needs to be done on client, so you are dependent on the user's network conditions. Okay, so next we have like we have server-side rendering. With server-side rendering, instead of what we do is, instead of uh, running all the code on client, uh, take the we take the component, we run React's, we first fetch all the relevant data that we need to do on the server itself, and then we use React's render to string method to get all the HTML, and then we serve this HTML to the client, which leads to a fast first contentful paint. Uh, Although the user would still need to download client-side JavaScript, like to make the page interactive, which is a process called hydration. So I'll just show you with the illustration on how it works. So again, we have the same app. This time, what we do is in the beginning, we run this code, we run the client's JavaScript on the server, which gives us, we first fetch all the data and then run this code on the via render to string, which gives us the initial HTML, and then we serve it to the client. So if you see, like right now in this HTML, we have all the details for rendering the page. Okay, so we have the title, content, and everything. So once the browser passes the HTML, it leads to a very good first contentful paint and largest contentful paint. The boxes are gray here. The gray part here represents that the user cannot start interacting with the app yet because we don't have the JavaScript. So how it works is ki you tell React ki hey, this is the HTML that I generated on the server, and here's the JavaScript. So what React does is it generates the component tree in memory, and instead of generating DOM nodes like we saw in client-side rendering, it attaches the event listeners to the already pre-generated HTML we got from the server. So once that thing is done, we get our app becomes interactive and the users can start using it. So this is how again the network graphs look like. So we have a slow time to first byte because we need to fetch the data on the server and then convert it to HTML, then the browser. But we have a pretty good fast FCP and LCP. So the users at least have like something to see while the JavaScript is downloading. And then on the browser we hydrate the app, which when the app becomes interactive. So now where do the static site generation and incremental static generation fit in this? So with static site generation and incremental static regeneration, what like for example what Next.js does is it with static site generation it builds it generates the HTML at build time and caches it, and with incremental static regeneration it like caches it per request. So what it does is, since the HTML and the JSON etc are cached, so whenever user requests the page, they get the HTML immediately. So with SSG and ISR, the time to first byte reduces significantly. So that's the one benefit of these techniques, and that's why Next.js became so popular. But I think like it's not a silver bullet because you cannot use it everywhere. Like for example, if you want to render something based on users cookies or something like that, I mean it works best for public pages. That's the thing with static site generation. So with the pros are like, unlike CSR, like SEO is pretty good because web crawlers like can easily go through server rendered HTML, and since the first contentful paint and LCP are fast, the user at least have like something to see, like they can at least read stuff if they are on a slow network and the JavaScript isn't downloaded yet. The main con we saw is the slow time to first byte, and the other is the time to interactive still remains pretty much the same because the users still have to download the JavaScript, and still the page React has to generate the component tree and then attach the event listeners. So yeah. So I think like Dan in his discussion of new suspense architecture summarized it really well. The problem with SSR right now is that first you have to fetch everything before you can show anything. So you have to fetch all the data you need to show to the user on the server before you can show them anything. You have to load everything before you can hydrate anything, which means you have to the user have to download all the JavaScript and then hydrate all the whole app at once before the app can start being interactive. And again, lastly, we have like, you have to hydrate everything before you can interact with everything, which means that the user have to like, hydrate is currently single pass in React, so the whole app needs to be hydrated in one go before the user can start interacting with it. So to solve these problems, the React team has been working on the new rendering patterns that we'll be taking a look. So the first one is streaming server-side rendering. So what streaming server-side rendering means is that, first of all, streaming server-side rendering isn't something new. It has existed for like 4 years now. It was there in React 16 as well. And what it allows you to do is like we saw, there's render to string method in server side rendering. It added a new method called render to node stream. What it does is that it rendered your app as a front end, as a HTTP stream to the browser. So the browser can start receiving the HTML in chunks while the page is rendering. So it slightly helped improving time to first byte while still giving you the benefits of SSR. It also helped parallelizing requests, like the browser can start downloading the relevant JavaScript and CSS while it is being streamed. So again, like this, Max Stover wrote an article of like 4 years ago about how they used this method at Spectrum and how it improved the performance. So as you can see, like this illustrates it pretty well. With SSR, you have like render to string, and then you get the HTML output, and then you transfer the HTML, and then the client renders it. But with render node to stream, you don't have to wait for it to complete. Like you can start sending the HTML and the browser will start rendering it. Like you give it a chunk, browser will start rendering it, and then another chunk, and then the browser will render it again. So you can like stream it gradually. Okay, so this was before React 18, but with React 18, what the React team is doing is they have deprecated the render to node stream method, and they have introduced a new method called render to pipeable stream. So it has the same benefits of the previous method, but it unlocks a new architecture for suspense, which we'll see later, which allows us to fix the problem like we saw with server-side rendering just before. So what it unlocks is the new suspense architecture, and the new suspense architecture has like two really cool things. First is streaming HTML, like streaming, I'll show you like how it works, but how it is different from the normal streaming, and the other is selective hydration. So first start with streaming HTML. So with React 18, if you wrap a particular component in suspense, uh, it tells React to like display the fallback until the component is ready. So whenever on the initial page load, the user gets the fallback. The in the initial HTML stream, the user gets the fallback that we added to suspense, and once the data for the suspended part we have fetched the data for the suspended part on the server. The server can send that data to the same stream, and the React sends additional HTML into the same stream with some minimal inline script to pop it into the right place. So again, to how it works. So this is the same app, but let's assume that our comments are very slow. Like comments, the API is very slow and it takes a lot of time to fetch. So we wrapped it in suspense. What happens in initial HTML output is we get a spinner for comments. Okay, and so the browser first renders this, and once like the comments are fetched on the server, we just we just send the HTML to the same stream with some minimal like HTML. Like this is very simplified, like this I use from the React team's discussion, but like this is like a simplified version of how it will work to pop the comments in right place. Okay, and the next thing is selective hydration. So what selective hydration means is like, if you have like ever built React app, you must have used like react.lazy. So react.lazy allows you to split the uh, bundle of a particular component from the main bundle, and prior to React 18, code splitting with React Lazy only worked on the client side. So you couldn't do it on the server. You have to like do the whole render to string and then convert the HTML output. But with React 18 and the new suspense architecture, this works. The suspense, the lazy loading works on the with streaming server side rendering as well. And what it allows you to do is, apart from the streaming the HTML until the component is ready, it also allows you to like disconnect the hydration part. So even if like for example the comments are very slow to load, you can like start hydrating the rest of the app, so the users can start interacting with the rest of the apps even when the comments are still being streamed. So again, let's see our demo again. So this time we have wrapped, as I mentioned, the comments in suspense. Okay, so when we fetch the page, we get the same layout and everything, and we get the spinner for the comments uh, with the suspense fallback, which is a spinner. So this HTML gets streamed, and the browser passes the HTML, and this is somehow what it looks, and we have our first contentful paint at that time. So let's assume that the comments API is really slow and the server is still fetching the comments. So meanwhile the browser wouldn't wait for it and would start downloading the JavaScript for the rest of the app. So again, let's assume the JavaScript is downloaded and React has like executed the JavaScript and hydrated the rest of the app, but the comments are still loading. Now comments are streamed. The data relate for comments was fetched on the server and it was sent through the same stream. So the gray again represents here that they are not ready to be interacted yet. So they have like the HTML with in the stream itself. So we can start fetching the relevant JavaScript for the comments, and once the relevant JavaScript is fetched and we hydrate the comments as well, and again our app is fully interactive now. So the cool thing about this is ki even though let's assume ki the sidebar was also streaming and this was also streaming, and like both of them are streamed, but none of them are hydrated. So if the user like starts interacting something on the sidebar, React is smart enough to figure out ki hey, this person is interacting with the sidebar, so let's hydrate the sidebar first. So React will hydrate the sidebar first, while it will in parallel download the bundle for comments and other things as well. So again, if we see the network graph, so uh, it's again we have a pretty fast time to first byte. We pass the HTML and then we paint, and then like similar to like what we saw, uh, the browser can receive like chunk at any time, and then React will start hydrating it afterwards. So this can happen in any order. Like in this network graph, I have tried to show that this comment gets streamed, and then the uh, JavaScript bundle for the rest of the app comes first, and the comment bundle comes afterwards, so that we hydrate the whole app, and then the whole app is interactive. So now, so streaming improved the rendering thing significantly, but React team thought that maybe we can do even better. So in 2020, at the end of 2020, they released a new video. They released a new talk with a RFC of something called React Server Components. So what the React team realized is that before React 18, React has been primarily client centric. Like it has like been like that since forever. So what server components allow is developers to take leverage to leverage the server more and they enable like good performance by default. And they also like make it very easy to fetch data in React apps. So how they work is that React server components allows you to create components that render only on the server. So one of the benefits of that is that there is zero client-side bundle. There's no JavaScript for server-side components. They only render on the server and then are streamed to the client. Uh, the way you do that is by creating uh, components with files with .server.jsx or tsx extensions, and then what you do is like render the static markup on the server which has like zero impact on the bundle size. So but keep in mind like it's only perfect for the parts of the app that don't have any interactivity. So what I mean by that is like the React again the React team has given a great example. So as front-end developers we have to be very mindful about any third-party packages we use, right? So for example, they are using a markdown parsing library which is like 200 like even 63 kb gzipped. And so with server-side rendering, even though you have generated all the HTML on the server and it has no interactivity, and you send it to the browser would still download the JavaScript, all the JavaScript for like the markdown and everything, and then hydrate the app, which is not really necessary. So what we can do with React server components is like instead of nodes with markdown, we can call it nodes with markdown.server.jsx, and the code remains the same. So this way, the markup gets generated on the server and gets streamed to the client, and no JavaScript is downloaded. So again, I mean, you won't want any non-interactive apps. So server components can compose with client components really well. So one thing about that is server components, since they only render on the server, they cannot have any state effects or even event handlers. They are just for like rendering static markups. So what they can do is they can import client components and hand off the rendering to the client components. So what I mean by that is like, for example, we have the post thing, like same that we have been looking right now. So this is a server component and it renders the post. It it passes the markdown and generates the HTML, but it imports a add comment.client.jsx. So client components will have to use the client.jsx extensions. So the client component has everything, the state, and it has the on submit event, etc. So what it means is that when the page is rendered, the server component would be streamed and the client component will also be streamed, but the client component would also be hydrated, so it can become interactive. Another thing is they can access the backend directly. You can like literally access your backend only resources directly in your server components because they only run on the server. So that's one advantage. And they have many other features as well, like automatic code splitting. Like we saw with react.lazy, you have to like, even on the client side, and you have to manually remember to use react.lazy. What server components do is like they treat all client imports as like potential code split points, and since you will know on the server like which component you are using pretty early, so you will download the JavaScript only for that component. And also they can preserve client state when reloaded. So what this means is like if you want to like reload something, like something got updated and you want to reload, so what server components do is like they can be reloaded without reloading the page, and it preserves the client state. Even the focus and the animation, they can keep on happening while the server components will be refetched. Like the way it works is because it uses a system that is richer than HTML. They don't use HTML but some other method. Okay, so lastly, again, let's see our app again with server components, but keep in mind this time the sidebar is a server component, that's why I have named it this way. The post is also a server component. The comments in navbar are still client components. Okay, and we have wrapped both post and comments in suspense. So one thing I forgot to mention is that server components work with suspense out of the box. So all the features we saw with streaming SSR just work out of the box here. So again, we get the HTML is streamed. This time we get spinner for both post content and the comments. Uh, so again, the browser passes the HTML, and the nav bar and the sidebar the user can see with the suspense fallbacks, and the user can start downloading once these are streamed, the user can start downloading the app, the JavaScript for hydrating relevant client components. So in our case, the navbar was a client component, but the sidebar wasn't. So we download the necessary JavaScript to hydrate it. So let's assume the navbar gets hydrated, and the post and the comments also get streamed in. So now we download the necessary JavaScript for comments, and yeah, the as you can see, like, we didn't need to hydrate the sidebar and the post content because they were server components and they don't need any hydration. They just render on the server and then stream to the client. So yeah, that's mainly it. That's the uh, that's what the React team has been working on. That's like the future of what rendering in React looks like. So I mean, you might ask, like, when can I start using these features? So the answer is, like, not yet, because you cannot use these in production apps right now because most of the APIs are still not ready, and server components, like I mentioned, are still in alpha, so they aren't really stable yet. But the React team has mentioned, like, the things we saw, like the streaming SSR and both server components rely on suspense for data fetching. And suspense for, as of today, suspense for data fetching, what React team plans to do is, like, release it as a minor version, and it will have like a bunch of things like React IO libraries like React Fetch, which then data fetching libraries could use internally to give us the abilities. And it also has like built-in suspense cache and server components like we saw. So this will be done after, like, once in a React minor release. And then also one thing you should keep an eye out is the layouts RFC by the Next.js team. They are also themselves calling it the biggest update to Next.js since it was released. So it is built such that to take advantage of the React 18 features that we just discussed. So should definitely check it out. I think they might announce something in the October conference that they are having. So yeah, that's mainly it. And these are the references that I use for this talk. The new the majority of my talk based on the new suspense architecture discussion by Dan Abramov, and you can also check out the server components RFC and talk on the React.js website, and the Next.js server components demo. And these are a couple of articles which I found interesting and used a couple of things in my talk. And then you can also check out the demos, like as I mentioned, that the demos are also kind of like shaky. They don't work perfectly. They use a bit of hack. So that's why I didn't show the demos here. So you can check out the demos. You can check out the code, how it works. Yeah, that's it. Any questions?
Hey, thanks. Great talk. So, a couple of questions. You mentioned, from what I have read, I understand that even when the selective hydration is taking place, if the user interacts with some particular component, the React will prioritize
Yeah, that's
hydrating that first,
yeah,
right?
that's
So, a question over there is it possible that, let's say that a particular, this is a very edge case I'm just thinking about, is it possible that when the streaming HTML has started, and one of the components, like, because we are code splitting everything, so not each bundle will have React, right?
no, the HTML, like, the streaming happens for HTML only.
Yeah, I got that. So when we are code splitting, the bundles, because the bundles have been code split for each component now,
Yeah.
is it basically, is it possible that the browser tries to hydrate a component even before it has downloaded React itself?
I mean, it's not possible. Like, you need to download React. So, I mean, React would be part of some of the main bundle. React would be downloaded, then the component code would be downloaded, then only the component can be hydrated. You still need React to download React.
Okay, and second question was the server components. I think the problem that this solves is even with streaming, server-side rendering and all, you are basically still at the end of the day rendering the app on the server and the client. I think this is directly solving that. Uh, I just wanted to check if you had any views on what Astro is doing with the island architecture. Is it similar in some ways to that?
Yeah, I mean, I have heard about Astro. I never got to try it, but yeah, I have seen that they also do the same thing, that you can hydrate some components and uh, no, and even like hydrate only when you scroll to them, those kind of things. So I guess it's similar, but like server components also have like these other features that they can reload while preserving the client state and those kind of things, which I'm not sure if Astro has them.
All right, thank you.
Anyone else?
Thank you.
Thanks, Prateek. Thanks for the insightful talk. Guys, I would like to invite Pulkit. He's here to talk about writing performant UI components. And Pulkit works at Flipkart.
So, hi everyone, my name is Pulkit and I work as a UI engineer at Flipkart, and I primarily work on the Flipkart ads platform. And sorry, yeah, so I work in primarily in the Flipkart ads platform. Sorry for the goof up.
DHCP guide like content is.
It is visible there.
You need a different connector or something?
Yes, I think so. Hello.
Do you need a different connector? Do you have only slides?
There's a demo also. What was it?
Windows. System. Next one. The moment you put less slide, it's going away.
It randomly goes out.
So how much of your presentation will affect if you switch to another laptop? Another Mac?
I can switch to another one. There are two components that I need to demo. Both is available.
You see, maybe at least we'll get the presentation part done, right? If you can skip demos, maybe.
Demo is the main part.
No, it's not working with his laptop.
No, it was working, but I don't know.
Yeah, it's
Suddenly the green screen is
getting disconnected in between.
Can you see same level?
Presentation के लिए कर लो demo.
No, demo, like do you need to run something? What you need to do?
One thing is a local boot. Second thing is a code sandbox.
Code sandbox, it's a link, right?
Code sandbox is a link. Second thing I ran on the
I think his Mac will have everything, right? Do you want? He can run some code on your machine. Code? Demo.
code sandbox.
Code sandbox पे चला ले.
हाँ.
Put the second thing also in code sandbox, not possible.
Not possible that quickly, but you want to go next.
Okay, do one thing. Let him go second. Meanwhile, you put this code in the code sandbox.
Sure,
Once
sure.
his talk is done, you can switch to his laptop and present everything.
Okay.
Okay?
उधर क्यों आता है? उधर नहीं आता.
So guys, while we figure out the video issue, we'll have Siddhant go next. So Siddhant will be talking about revamping Razorpay documentation website.
Hey folks, I'll just quickly. Turn it. Do we have another connector? Okay. I think mirroring is the issue. One second. Oh God. Let me just charge it. That is doing something. Okay, I think things are finally working. So, hi, I'm Siddhant. I work in Razorpay as a developer experience engineer. So, our job is to help Razorpay developers or external developers who are working in Razorpay their lives easier. So, as part of that, I work on the documentation where we are working on revamping it. So, I'm just going to talk about our experience and our journey so far. So a little bit of a background about the documentation side. So this was first launched in 2015, and it basically covers content around all the products that Razorpay has. It just gives a brief and details both around the products. And the second part to it is explaining the APIs. So whatever APIs Razorpay supports, our documentation basically gives information around that. So as I mentioned, this was built in 2015 first, and while it has gone through a couple of iterations, there were certain problems that we noticed with our website. So first and foremost was the build system that we were using was quite unreliable. What that meant was we were seeing a lot of production issues, ranging from, let's say, the content is broken, or whatever links we have given, they might not work or may work. So that was a really big problem that we faced. Another thing that we faced was around customer satisfaction. Our developers were, the developers who were using the documentation had quite a few times pointed out various pain points that they suffered. Um, Third was around the internal developer experience. We know that internal developer experience is really good, really important for fixing bugs early or keeping developers happy in general. So again, being an old system, this was a little subpar for us. And finally, last but not the least, so we have a tech writers team who actually manage the content. Whatever content we see on documentation is managed by that team, and their experience and their processes were completely broken. There were a lot of issues which hindered the speed and reliability with which they could generate new content. Sorry. So yeah, given these issues, we decided that we need to do something about it, and we wanted to move to a new system. We targeted three main aspects with this move. One was, the first one and the foremost one was to improve our users' experience and the quality of content that our documentation can give them. The second was to improve the tech writing or content writing processes, so that, again, this ties with the first point as well, that if we can make the processes faster, the content that our users will get will be much, much better. And lastly, we wanted to improve our own developer experience. So we didn't want to wake up at 1 a.m. To see some content is broken or wrongly rendered. So I won't be going into much detail about the old system, but this is just an overview. In the old system, we were using jQuery, and while it is great, we wanted to move to React so that both the developers' experience as well as their speed could be increased. As for the content, our content is written in Markdown, and we were using a library called Markdown.net to basically convert the Markdown into HTML. Instead of that library, we wanted to something called MDX, which we'll look into it a bit later. So moving to a new system or migrating to a new system is always a big task. The current system can have a lot of nuances, and you don't exactly understand always where there can be things that can break. So we wanted to take the migration in multiple phases so that we can ensure that our website is up and we don't take too much at once. So with that philosophy, we divided the move in 3 phases. The first phase was to replace jQuery and our previous system with the React-based system. The second one was to update our parsers. So as I mentioned, we were using something called Markdown.net. We wanted to move to something called MDX, which will help us parse our Markdown content reliably into HTML. And finally, we wanted to make our docs much more interactive. So if you see our previous docs, they seem like a normal HTML-based website. They don't really have much interactivity. So that is a big push that we wanted to make, which will eventually improve our users' experience. Cool. So since we divided the move itself in 3 phases, this talk will just cover the first phase, where we'll talk about how we moved to a React-based system. So for us to move to a React-based system, there were 2 parts that we needed to solve. First was how do we render a Markdown file in React, and the second one was how do we take all the content files and render them in our website. So the challenge here for us was that we have more than 1,300 pages in our documentation website, and we wanted to figure out the best way to render it in a React-based website. So let's start with the first point, like how do we render Markdown? So for this, we initially came up with 2 options. Option 1 was to just import Markdown into a component, convert that to HTML, and just render it. So if you look at the code here, this is just pseudocode. We are importing the Markdown from a content file. Then we are using our Markdown-based parser to convert it into content, and then we are basically setting it, basically injecting it into our React tree. So that was our first option. This would allow us to continue using whatever plugins or whatever extra custom components that we already support. It'll allow us to continue using them while we change our underlying system. Another option that we considered was to generate this HTML beforehand and just pass it to a dummy component which will just render it. So in option 1, we identified a couple of issues. First was if we are going to create a component for each of this content file, doing it manually is not something that we wanted to do, given that we had 1300 pages. So that was one issue with option 1. And the second issue was that the content parsers that we have, those were basically not client safe. What I mean by that is they were written for the server and they were written in such a way that they will run on a server itself. Now, if we were to run this on the client, that would cause our website to break. So given these two issues, we just wanted to quickly move on with the POC. So we went ahead with the option 2. So now that we have figured out how to render a markdown, the second part is something that we wanted to tackle, which is how do we create all the routes for our website. So again, here we had 3 options. Option 1 was to write it manually. So writing 1300 content components manually was something we didn't want to do, definitely. So then there was another option where we thought that since our tech writers already manage the content, they can also help us by managing a config file, which will have all the routes that are required to be rendered. While this seems like a better solution, there were a couple of issues with this. One was that maintaining another separate file would mean that we have 2 sources of truth. One is the content itself, and the second is a config file. And keeping this content file, this config file, and all the content in sync is something which is going to be very difficult and is very error prone. And building on an error prone thing, if we are asking tech writers to write a config file by hand, there will most likely be typos in the way they define the routes. So given this, we wanted to move to a more automated system, which was our option 3, where we thought if this config file is basically dependent on the content, why not just generate it ourselves? So that is what we did. We basically relied on the file system. The way the content was written, the way the content was nested, is how it will show up on the website. So given that, we basically came up with 3 steps, a 3-step procedure, which will basically create a route config for us. So number 1, basically go through all the content, figure out all the files that are there. Now for each file, based on its nested path, we are going to generate a path where it will be rendered on our website. Once we have this path ready, what we do is, from the content file, we read all the markdown content. We already have our markdown-based parsers that we talked about earlier. We use them, generate HTML, and we return that to as a route object. I think code will be much better here, so let me just quickly show some code. Yeah. So as you can see, we basically read all the files. For each file, we get the path where we want to render it. We read the markdown, we converted it to HTML, and we just return it as a route object. Now, I'm very glad that Pulkit went ahead of me because he was able to explain the different rendering mechanisms. So we were basically using one of those, which is called SSG. So we took this route config, we inputted that into our SSG system. Voila, our website started working. So we were really happy at this point that our POC was successful, or so we thought. So after running this website, we basically stepped into some issues. I'm going to ask one of you folks, or any one of you folks, if you can notice something here. Any issue that you might have noticed. Yeah. So I got size of the bundle, which is exactly correct. So if you see closely, we are transferring close to, more than 3 MB of data just for a single bundle, and this is just a condensed. Okay. Okay, sorry about that. We are just, so the main bundle itself is 3.3 MB, and that's gzipped. So this was a big problem for us. We had a huge bundle size, and as I mentioned multiple times, we had 1300 pages, and at this scale, this was just unusable. And this is how we felt. Right, so we thought, okay, let's go about debugging it. So this is just a snapshot from a tool called Bundle Analyzer. It's basically a plugin for Webpack which tells us information around what your bundle consists of. So if you just focus on the main bundle here, you'll see there's source, there's something called temp, which we can ignore for now, and there's something called routes. And below that, there's a humongous temp content routes. Notwithstanding the names, basically our idea was that this content routes will have the config file which we just generated. But as you can see, that is taking the majority of our bundle. So we did find the issue. Our bundle is basically having all the markdown files that we have, basically bundled into one single main bundle. So this means that if you load any of the 1300 pages, you are loading all your pages in one go. So it's not an SSD system, it's not completely a CSR system, it's somewhere in between. So we were quite taken aback. We should have looked at it before, as in like anticipated this. So we're thinking, what should we do? Should we tweak our parsers so that it's client side only, and we probably move to an SSR or a CSR based system, or even an SSD system would work in that case? Should we just drop this phase? Should we just move on to phase 2? Because phase 2 has MDX, and MDX can easily help us with this. We'll go into detail why. Or just go on a long vacation till React server components are shipped. And again, I'm very grateful because I don't have to explain React server components. Cool. So looking at this, we thought let's just take a step back and let's analyze what is going wrong. So we know that our main bundle is bundling all our files. So how do we go about, or how do we fundamentally not bundle everything in a single bundle? And this is a question to the audience. How do we ensure that not all our files are bundled into a single bundle? Come on, you just heard a nice talk on that. Yeah, code splitting, I heard that somewhere. So yeah, so now we know we need to do code splitting. But how do we do it? That was a question in our head. Code splitting basically works for JavaScript, but our content files were empty files. So how can we possibly do code splitting here? Okay, so we thought, what if we create a component for each of these content pages? We have a JavaScript component which will contain all the content that we have. And that way, that was our aha moment. So that way we can basically do code splitting and split our bundles for each of the content pages. So that is what we ended up doing. We basically updated our automated route config generator. If you see, this was the old one where we were, if you notice, 2.2, we were reading the markdown and we were converting it to HTML, and we were just returning that in the route object. But now we decided to take that HTML and inject that into a React component itself, and just pass the component name back in the routes config. So that way, whenever we are rendering a system, we'll just render a component instead. I'll just quickly show a little bit of code. So this was the earlier code. If you notice again, we are basically returning HTML where we have written content. Now if you check it, we are, after converting to HTML, we are basically generating a component, and from that component, we are just passing the component name into the routes config. This is how our routes file looks like now. So there's just one route right now, but imagine there are 1300 such routes. We define the path, and then we define a render function. And within that render function, we pass the component name that needs to be rendered or that particular path. And within render out, we are basically lazy loading that component. Now on lazy loading, what Webpack or any other bundler does is basically split your bundle at that point of time. So if you see here closely, all our paths are now code splitted. Okay, so what was the result? A scalable website. And that's how I felt after this. If we see the updated network bundle, we have cut down all the way from 20, okay, I actually forgot, some 20 odd MB down to 2 MB, and gzipped is less than 1/10. So I know this is not the best right now, but for us, this drastic change was required for this project to even go ahead. This is our website, and if you see the updated bundle analyzer, you see those index.md bundles everywhere. Those are all our independent code, independent content. Cool. That is pretty much it. Let's just quickly have a recap. To move to for phase 1, we wanted to figure out how to render Markdown in React. So this is basically based on our constraints that we already have plugins that are built, we already have content which is written based on those plugins. We wanted to figure out what routing approach we should choose. Once we decided on those two, we went ahead with a POC, which miserably failed. So we had to figure out how to improve the issues that were there. We went back to our basics, we reconsidered what we were doing, and we finally fixed the issues that we got. Right, so after phase 1, the future holds phase 2 and phase 3. So in phase 2, we'll basically move to MDX. MDX will be a much better improvement for our parsers, given that it's based on unified. Again, that can be a whole talk on itself. But yeah, in short, it gives us a very predictable way of parsing our Markdown and converting that to HTML, and it gives a very easy way to extend the interactivity in the website, which is what phase 3 is going to be about. Yeah, that was me. Any questions?
Hi, thanks for the talk. I just have one question.
Mm-hmm.
Like, at what point did you realize the bottlenecks of your basically documentation management that you decided to build your own website instead of using something like open source blogging tools like Ghost? Because like they have great API support, you can connect it directly to your database, get data from there, and yes, I understand the trade-off is that your website won't look very nice. You'll have to do the UI work still. But a lot of that data management, that could have been, the heavy lifting could have been done by that open source tool. So what were the bottlenecks there?
Right, that's a very valid question, and that is a question that we also asked ourselves before moving on to our own system. So we have a lot of constraints around what kind of an existing system we already had, right? We had a lot of custom components or custom code that was already written on top of Markdown, which will not be supported by third parties very, very easily. Our system was based on GitHub, and we had a lot of tooling that was already there around it, right? So we didn't want to throw all of it away to move to a separate system. We did try to use something like Docusaurus, but at Docusaurus V1 was not something that was fitting our builds. Probably we can look at Docusaurus again with V2. That has quite a good feature set, but even then I'm pretty sure that there are things that are specific to Razorpay or our system or our tooling, which required us to build our own.
Oh, thanks.
Anyone else would like to ask a question?
All right, thank you. If you have any more questions, just reach out to me on Twitter.
Thanks, Siddharth. So So guys, while we figure out the AV issues, we'll take a break now. So we have like refreshments and coffee. Please help yourself with it, and we'll be back in 20 minutes and then continue the rest of the 3 talks that we have scheduled. Yep. Thanks guys.
इश्यूज आ रहे हैं चार्जर के साथ डिस्टर्बेंस है जो भी कह लो
Arey, didn't look like your first talk. Good talk. Really good talk.
Try with this connector. Let's see.
I have the same one as well.
Just a minute.
For the laptops, whichever is creating dual profile, that has a problem. Yes.
This thing, can you do anything on this?
No, that's a panel. Replace the panel. So this is good, right? No videos, right? By any chance?
No videos.
Achha, then this works.
Actually,
Remove cable.
It will work.
Yeah, just we'll test it. Try that M1 Pro. If that is not working, use the same sharing Pro. Yeah,
I
just
can move this around.
you can sit anywhere and display. But no charger. That's okay. You keep it like this. Okay. Sorry.
Just checking the sandbox link if it is.
You also yes.
Share
Probably
link?
LAN should be.
No. Just first to see this functionality. Just listen. Bro, can you check is there any lag and all when you are switching the screens? Is it seamless, right?
It is not switching now.
I think this.
It is actually not switching anymore. It's actually not switching.
Stop sharing.
Stop sharing.
No, the example is more like for everything.
No, where did we open that website?
This is the website.
No.
What's that website?
The number.
This.
It's not sharing.
Screen switches on. Okay, just testing that. Everything else is working.
Entire screen I'm sharing.
Entire screen.
So this is your sharing Pro. Okay, in case something is not working, you may.
Let me do one thing. I can do one thing.
Switching.
मैं इसको यहीं ले आता हूँ.
You can take that. It's working, right?
Seems to be working.
No, just check if something is not working, we will help you. Yes, screen switching is happening. So
Make sure that it's working.
screen share link.
It is working. I think screen switching is also working. The presentation is there. Screen switching working. I don't need anything else.
Okay.
So when I come, you need to enter the password and everything again.
This is directly working by God's grace. yeah. So share link on.
It is gone.
Right.
Is it working now?
is it working?
We should not disturb that.
No, then the green screen.
Hey, where is our connector? C connector?
Yes. Here.
Try with this.
It's again same.
Some connector.
Mine is the ISM.
Oh, sir.
Where do you work?
work for a company called Frequent, sorry.
So it's a problem with M1 or is there
If
any?
it's not working with the Intel model, then I think it should be something to do with the adapter. I have a similar adapter.
Can please? Yeah, yeah.
Same one है मेरे पास. Apple doesn't have an original. दिखता नहीं है अभी आजकल. Original तो यार 3-4 हज़ार का होता है. बहुत expensive.
Their converter.
हाँ.
वो तो
6,000 वो तो एक ही आएगा.
एक
बस.
I work with Flipkart.
आपका ऑफिस कोरमंगला में. अच्छा बेलनपुर. तो कोरमंगला में नहीं है अभी कुछ.
There is only one office that is in Embassy Technology, which is in Melanpur. Where do you work? Place.
So we used to work in the same office.
Okay, nice.
Pre-pandemic, same company. लेकिन हम लोग अभी ज़्यादा हैं. I think we have about like 260 plus.
260. Oh.
Only
Liva cannot accommodate that.
Yeah. So we got our own building. अभी renovation हो रहा है. That's near UB City.
अच्छा.
तो उसके लिए इतना रोना पड़ा था सबको कि यार मत रखो बेलनपुर.
बेलनपुर तो यहाँ से
बहुत दूर है. Like literally दूर. तो इसीलिए बोला यार कि पास में रखो. ट्रैवल टाइम थोड़ा था.
वीकडे में तो बहुत.
हाँ. बोले ऑफिस आओगे. वो देखेंगे पहले रखो तो सही. वो अलग बात है कि आएंगे मन होगा तो ठीक है. ऐसा 2.5 साल तो चला लिया अभी घर से ही. अभी ऐसा ऑफिस आके क्या करना है.
Ours is hybrid.
हाइब्रिड है ना.
2-3 days नहीं. We have to go to.
अच्छा जाना है.
We have to be in Bangalore. Sir. You cannot be. I am from Delhi by the way, but.
वो दिल्ली से हो. साउथ दिल्ली.
No.
NCR right?
हाँ.
So how many years
Bangalore has just been 4-5 months.
Who is it? How do you like weather के सिवा?
I mean it's okay still coping up with few things.
Yeah. Food is.
Food. So you are originally from Bangalore?
I'm originally from Bangalore, but
So you must like.
no, I've been around. मैं मुंबई में था. पहले की food वही था. Delhi also.
I know that.
Main display.
Kajuri Garden.
I've been traveling. So
Food is a problem and we have to address it.
it's there are very few places that you need to know. And ऐसा भी नहीं है कि taste ऐसा ही रहेगा.
Correct.
When I was working, we had a dabba.
अच्छा.
80 रुपए में used to be like 3 roti that stuff. Sorted. So now all that is closed. वो भी बंद करके यूपी चला गया. ऐसे कौन लेगा?
यूपी में स्टार्ट करते हैं.
यूपी में
स्टार्टअप.
हाँ वो गया नोएडा.
अच्छा नोएडा में चल जाता है.
चल जाता है.
कंपनीज देयर ग्रेटर नोएडा.
हाँ वो तो बोल रहा है सर वहाँ तो सब खुल गया है.
हाँ दिल्ली में यहाँ भी हो गया. एटलीस्ट पीपल वेयर मास्क.
यहाँ पे तो
What did you talk about?
Microfrontends and SSR.
Oh, nice.
I was
A lot of people are talking about SSR today.
हाँ यार ये अभी कंपनी में दिक्कत हो गया. बहुत परफॉर्मेंस बहुत खराब करके रखा है.
So there used to be an engineer
So
called
keep sharing ready.
really talented guy. He built the entire SSR thing for our.
अच्छा SSR पे चलता है.
Something happens, stop the share and reshare the screen.
So rendered to string and had it all that.
अच्छा वो
हाँ उसने चलाया था. I have not built it.
Reset है.
I think what we are trying to
Same window.
पता था कि ये
1 minute.
Completed कोई नहीं है इसका. हाँ he's a talented guy.
तो मैंने बिग फाइट चेक किया. बिग फाइट was the first. Then there couple of music line करके Zolando से. But the problem
Simple. So, why you are throwing all this here?
then the problem is I spoke to one of the developers.
I asked you to keep now. Why you are?
Issues open नहीं हो रहे हैं. कोई यूज नहीं कर रहा है. कुछ समझ कर रहा है. I think.
ಒಂದು ಆ್ಯಪ್
हाँ ಹೇಳಿ.
ಇದೇ ಥರ
ಹೌದಾ?
Type 10 189 11 117.
10 189.
11
ನೋ ಫುಡ್
I just need one slide. Better if I can share the screen.
So it is working.
Yeah, it will work. Some M1 Pros has some issue. Because we tested everything, but M1 Pro we don't have access.
Buy new M1 Pro.
We have to do what exactly happening, whether Xtron is not supporting or it's a problem with my.
You work for Vivo.
Yes, I take care of audio visual operations panel.
Tell them to reimburse, buy one M1.
Really munche on company.
I don't know. You don't. I'm from Hyderabad. Okay.
I used to work with.
Yeah, this will.
And I was not aware there was such a big one.
No, recently we opened this. This is the first event actually. Externally.
All set? Set.
M1 Pro has some issue. M1 Pro is creating two profiles. One duplicate profile on our with our device name. That's where problem comes. Not sure it's actually M1 Pro issue or our issue.
This one.
We are not sure. But we have an alternate option to which is everyone, anyone can present any language. That's what we tested.
Yeah. अच्छा तुमने भी ऐप से शायद बेटर है आप किया है
क्या? This one. This is web only. Canva.
Yes, from application. Code is 7 to 40. Should I ask for one more password, one code? Enter 7 to 40. We'll share once. This is all. Yes.
Yeah, no, I mean it happens all the time. People ask you, but they don't show up. Like different reasons. Like because it's very easy to ask you, right? Because it's free and everything.
Yes.
Our always estimate is there are like 400 silos. Yes, get 100. Even less than that. Right? Starting from this is the first exercise.
stop sharing. Now you are at the right? Perfect. He will help you. He will be sitting here.
I just share this. It should be good. This
Done.
इतना हो गया तो काफी है. I'll just keep this link open, na?
Just keep open and once you start sharing, just start it on sharing.
Gotcha. Done. Thanks. All the best.
I think you are good.
Using the presentation on the bigger part and your
Sarji, please. If something goes wrong, don't get tense. Presence of mind. We are doing from the web sharing. Enter the IP. That's all. Code is that. Password is 1433. No, other tab. Nagraj. Nagraj, that is in different tab. Not in this window. One more session is there.
This one, right?
Yes, stop.
Okay, guys, if you want to move forward, there's a lot of space here. And we'll start with this quiz. So, yeah, we're going to start with this quiz. You'll have to, like, sign into, like, joinmyquiz.com and just enter that code so that you can play this game. And we have some interesting prizes that you guys can win. So, go ahead. And we have, like, a lot of space in the front if you guys want to move front. That would be good. Yeah, guys, please try now. Guys, anyone else who's yet to sign? Can I start? Anyone wants me to wait? Okay. We'll start. So we have Abhishek leading so far. It's fastest fingers first, guys. Root SRK. Nice. We added some fun questions as well, guys. This seems to have like completed faster participation. Mousepad. Funny name. This was faster than iPhone. Nice. There's one person who isn't participating at all. The iPhone 14 because it's new nightmare for you guys to be make it responsive. I don't know how you will deal with Adobe acquiring Figma. Oh, paprika. Nice. Just a disclaimer, we're not being sponsored by any sports website or news website. Just to make it fun, we've added these questions. The last one is going to be really important, so. uh, Okay, go for it. So this we definitely sponsored. So. So we'll have Pulkit talking about writing performant UI components.
Hi everyone, again. So, so I work as a UI engineer at Flipkart, and today I'll be talking about writing performant UI components. So if I have to divide performance into two types, I can broadly divide that into two types. One is load time performance and the other is in-app performance. Now, see, the major focus will be on in-app performance, how to improve it, just to understand about it. But let's first also understand what is load time performance and why it is important. So in the previous talks, we've heard terms like FCP, LCP, or time to interactive. So load time performance is actually what constitutes load time performance is actually these metrics: FCP, LCP, or let's say time to interactive. Now, if you talk about Google as a search engine, okay, it actually lays a lot of emphasis on having a good load time performance. Not only does this, lays a lot of emphasis on this thing, but it actually provides you tools like Lighthouse, where you can actually measure your website score, where it also suggests you areas where you can improve and have a good load time performance. Also, if we even keep that aside, right? So let's say when a user first lands on your website, and let's say your website does not have any content, let's say for the first few seconds, the chances are very high that he's going to bounce off. Okay. Next thing is, even if let's say the content is available, but you are doing a lot of heavy lifting on the UI thread, or you are doing a lot of heavy lifting through JavaScript, then also let's say your website is not interactive for the first few seconds, even if the content is available, then also the chances are high that generally the user is going to bounce off to some other website. Okay. So these matrices and these scores you can calculate through Lighthouse, and a high Lighthouse score is actually important for Google because it actually changes the ranking of the targeted website. So if you are a website owner or a business owner, it is actually really important to get your website results in the first few results, because generally people do not go to the second or let's say the third page. So it is very, very crucial to get your website in the first few results. And performance score, load time score, or like even if you call it Lighthouse score, this is one of those aspects which decides the ranking of your website. It is one of the very crucial aspects, but not the only aspect. Okay. Second thing is, let's say if your website is slow, and if like Google concludes that your website is slow, then it says that it is a problem for usability and SEO. Okay, because just like I mentioned, because people generally don't like to wait, users will generally bounce off to another website. Okay, and this is why load time performance plays a crucial role. Now we just talked about load time performance and why it is important, why metrics like FCP, LCP, these things are important, because you want to leave a good impression on the user when he first lands on your website. But an equally important thing is in-app performance. Now, what exactly is in-app performance? So I'll take advertising.flipkart.com as an example. So advertising.flipkart.com is actually a place where brands come, brands or sellers, they create their advertisements, and these are the same advertisements that you see on Flipkart's website. These are the same advertisements. So now, see, if we see the, and I'll take an example. Let's say this is the sale period, okay? Now the thing is, during the sale period, every brand or seller, you know, they want to create more and more advertisement campaigns just to get their advertisements out there on Flipkart. So as to grab more eyeballs and get the uptake in revenue. So if we try to understand the intent of the user here, so the intent of the user is to create more and more advertisement campaigns in the shortest time possible because they want to get their advertisements out there. Now, let's say your advertisement creation flow involves a lot of visual changes, okay? A lot of visual changes. Then let's say if the experience is janky, or let's say your website free or your creation flow freezes here and there every now and then that is a very frustrating experience for the user. Even if your load time performance is good here, but let's say if you're compromising on the in-app performance in such a crucial case, in such an important case, then the user will be frustrated, okay? And then the purpose is defeated, because the purpose here is to get more and more advertisement campaigns out there. And for that, if your flow involves a lot of visual changes, you need to have a good in-app performance. So this is exactly one example where in-app performance plays a major role, okay? But now, see, in-app performance, actually, it is what constitutes in-app performance. These are a lot of things like API latencies, your response times, your page-to-page transitions, all these things. Or let's say there is a very complex component that you've built, let's say file upload, where you are doing a lot of heavy lifting on JavaScript. But the focus today will be to talk about components that are visually more complex and not on API latencies and all of that. But yeah, in-app performance also includes these things. But the focus will be on talking about components that are visually more complex and how can we ensure that they are performant. Because we are saying that, okay, our creation flow or our advertisement creation flow, it actually involves a lot of visual changes. So the focus will be on optimizing those UI components. Now, what happens in the pixel to screen pipeline? What happens when a new frame is generated on the website? So these are the steps, okay? These are actually the, not the step, but these are the components that are, you know, included in the pixel to screen pipeline. Whatever you write, whatever code you write, how is it finally converted to the pixels or the frame that you see? JavaScript style, layout, paint, and composition. These things are a part of the pixel to screen pipeline. Let's first understand how these things work. So what are these operations and the cost of each operation? Okay. So when you first load the web page, what happens is your HTML is converted to a DOM, and your styles are actually converted to a separate CSS tree. Okay. Then what happens is when you load the web page, your HTML is a DOM and your style is converted to a CSS tree, which is combined to form a render tree. Okay. Now the render tree is formed. Now what happens is when your render tree is there, every element, every DOM element has now a style associated with it, because you have combined the tree and the tree is now called as a render tree. Now this is the layout part. This is the part where you calculate the geometry of every element, or in other words, where to place the element on the screen. Now this actually depends upon the width, height, or you know, properties like top, left, all these things that determine where the element has to be placed on the screen. This part is called as the layout. Okay. Next thing is, now that you have decided where your elements have to be placed on the screen, the next piece in the pipeline is painting. Painting is actually plotting those pixels, plotting those properties like background color, whatever you define in your CSS, this has to be plotted. Whatever is visual, whatever is visible to the user has to be plotted. Now paint is exactly this part. It is the process of filling in the pixels. Okay, and now the thing is, every browser has its own rendering engine. Google Chrome will have its own rendering engine, Firefox will have its own rendering engine. But the thing is, so the painting process actually depends upon the rendering engine also, because they use some auxiliary data structures which depends upon the rendering engine. Okay. Now what happens is, for every element there is a style associated. You define properties like color, background color, or let's say any other property like text align. Now what happens is, these elements are actually painted into different layers. They are actually painted into different or multiple layers. Now this information of painting or plotting those pixels into multiple layers is passed on to the compositor. Now compositor, its job is actually to combine those layers in the correct order. Now this actually is the most powerful piece in the pipeline, compositor. Why? Because these three things, layout or painting, these things actually happen in the main thread of the rendering process. So rendering is a process in a browser And these things actually they don't have a separate thread for it. They happen in the main thread of the rendering process, layout or paint. But compositor, okay, the thing to note here is that compositor has its own separate thread. And the most important thing or the highlight is that compositor can access your GPU. Okay, so it can access your GPU and it is faster. Now the thing is, there are some properties like translate, scale, rotate, which the compositor is capable of handling on its own. It does not require painting or layout. So let's consider an example. Let's say you write some JavaScript code to add a class to an element. Okay, you write some JavaScript code, you add a class to that element. Now what will happen is, let's say in that class you are changing the margin, let's say margin top of that element. Now what will happen is, layout part will trigger again, because now you change the margin top of the container. Now the geometry of that element, its siblings and let's say its children also will have to be calculated again. The geometry of that particular portion that is invalidated now has to be calculated again. So now the layout part comes in here. Now this is the inevitable part. Okay, even if you are changing the layout, but the paint part will also be triggered again. If you trigger the layout part, this in turn triggers the paint part also. Okay, and that then in turn it will trigger the compositor, because it has to combine the layers in the correct format. Now let's take another example. Let's say through the same JavaScript code, you add a class to your element, but that class changes only the background color. Okay, now background color is a visual property. It does not require any geometry or does not require any position, let's say position change on the website. Now layout will not kick in, because just like I said, geometry change or the positioning change is not required here. Painting will just change the background color, painting would be triggered, and then in turn it will trigger the compositor part. But just like I mentioned, there are some properties like opacity, translate, scaling, which will even not trigger these parts, okay, layout or paint. It will directly go to the compositor. Now why is it important to ignore these operations wherever we can ignore them? The reason is that most devices these days are 60 FPS, 60 frames per second. So every frame, if you see, every frame has roughly 16 milliseconds to get itself ready. And if the frame is not ready, the frame will be dropped. Okay, browser is going to drop your frame. And let's say if you want to accelerate this process, what we ideally want to do is we want to eliminate the pieces of the pipeline wherever we can. Okay, there are some parts which are inevitable. Let's say JavaScript you cannot ignore, because you are making visual changes or you are creating a new frame through JavaScript when you trigger a change. These things you cannot ignore, but what definitely we can ignore is layout, painting, and or maybe what we can do is we can delegate the work to the most powerful piece of this pipeline, which is compositor, wherever we can. Okay. However, there will be some cases where you would not be able to ignore these parts, but wherever we can, we should, because we want to accelerate the process of creating a new frame. Okay. So now what we are going to do is I am going to show you two examples, two components where we are going to use the same ground rules, and we'll see how performant they are. So this is actually a color picker component. So if you use the cursor to hover over the gradient, then you will see the X value here, and you will see the corresponding RGB values there. Okay, so what I'll do is I'll turn on paint flashing, which will tell you what parts of this component are being painted when I make any changes, which means when I create a new frame. I'll turn on paint flashing, and I will also turn on the FPS meter. Okay, so if I move this, okay, you see that there is a paint flashing green highlight here, and or the RGB values. Why? Because see, this is a part we cannot ignore. This is a visual change. Whenever you change something here, these values are visible to the user. They have to be changed. Okay, so this part is being painted again and again when you change. So that is why you see a paint flashing highlight here. Similarly for this color, because this is a visual change, you have to change the, let's say, the background color of this box. Now, but if you notice, okay, you do not see the paint flashing on this cursor. This circular cursor, you do not see any paint flashing here. Why? The reason is we are using, just like I mentioned, there are properties that the compositor is capable of handling on its own, like translate. So when you actually move it, we are actually translating it. We are not changing top, left or anything which triggers the geometry, which triggers the layout. Okay, so this is just triggering the compositor part, and compositor can handle it. That is why the reason is that you do not see a paint flashing here. Okay, next thing is, if you notice the FPS meter when I move this around, if you notice the FPS meter, if not 60, but it is close to 60 FPS. Okay. Next thing is, if I move the slider, you see paint flashing on the slider. Although I'm using translate here, this is being moved through translate, which the compositor can handle, but it is being painted. Why? Because I'm changing the background color of it. I mean, this part we cannot ignore because it has to be painted again. Okay, this is a visual change. As and when you move the slider's background color has to change. Okay. Sorry? No, circle, we are just picking. So this is actually a canvas. We are just picking the pixels from that canvas. I'll explain that in another example. So this actually brings me to the eyedropper. Okay. So what it does is, it zooms in this part. Okay. Now, when I zoomed in part, when I click on it, it just gives you the color value there. So now what we are using here is, when you click on this eyedropper, what happens is, we take a snapshot on the screen. So there we are using a tool called HTML to canvas. When you click on it, we take the snapshot of the entire screen. Okay, we take the snapshot of the entire screen, and let's say when you move this, so this actually is also, this circle is actually also a canvas. Now what happens is, when you move this around, we take the position. Okay, let's say we take the diameter of the circle and we get the pixels. Okay, we get the pixels out of the screenshot that you've taken earlier. Okay, let's say I move it here. We have one canvas which is the screenshot which we had created when you clicked on the eyedropper. The second thing is, this is also a canvas. This circle is also a canvas. We take the position of this, let's say we take the circular diameter into account. We get the pixels from the canvas, and what you see zoomed in is actually a scaled 2x version of those pixels. We just plot the pixels on this. Okay, just plot the pixels on this and scale it to 2x using the standard CSS properties, and that is why you see the zoomed in version. Okay. Now the thing is, this is being painted. This circle is being painted because we are changing the pixels on this canvas. This circle is also a canvas. We are changing the pixels on the canvas. That is why it has to be painted again. Whereas this cursor, this one, we are only getting the position here, and I suppose we are using it somewhere down the hierarchy. We get the position here, and then from this gradient, this background is actually also a canvas. So we get the position here, and we get the pixels at that position, which we change here, which we use to calculate the hex value and then the RGB values. Okay. Now next thing, also a very important thing here, is I will show you the layers. What are the layers that are painted here? If you see here, right, the slider, this thing has its own separate layer. Why? The reason is that we are using a property called as will change. Maybe in fact I'll show you that. We are using a property called will change. So will change is a property that beforehand tells the compositor that this property sometime is going to change in the future. So what the compositor does, it plots it, or it maintains a separate layer for that particular component. So this is why, this is precisely the reason. Maybe if I try to remove it and reload, the layer should not be there. So this is a way to optimize further. In a way you can tell the compositor, or you can inform the compositor beforehand that this is going to change, this is bound to change. Okay. So now if you look at the layers, the slider layer, this layer is gone. Because we have not used the will change property, compositor is not creating a separate layer for this. So the layer is gone. Okay, but having said that, will change should be used, I mean, very, very carefully, because browsers are out of the box very optimized. You should only use this property when you're very, very sure. And also we don't want to overload although your compositor can utilize your GPU, but the idea is not to overload it. Okay, because the browser itself is very optimized to do things. Next, let's come to a slightly more complex example, which is a slider component. Okay, same, I'll turn on the paint flashing for this also, and the FPS meter. Now if you notice the FPS meter, still not 60 FPS, but it is very, very close to 60 FPS. Now the thing that you see on the screen is, when I move the slider again, the slider is not being painted again. You see the paint flashing on the tooltip. Why? Because tooltip, see, this is a visual property, I have to change the number as you slide. Okay, so this has to be painted again, this cannot be ignored. But the slider again, we are using translate, which is a compositor only property. That is the reason it is not being painted again. The compositor enough is capable to handle this. Okay, layout is not triggered, paint is not triggered, the compositor can handle this on its own, and this applies to every slider here. But now the thing to note here is, and yeah, if I show you the layers again, I think all of this they have their own separate layers. So you see three small squares here, which are these layers actually. These sliders have their own layer because I have added a wheel chain to these sliders. Now the thing is, this color that you see, okay, slightly darker red here, okay, and the color variants that you see here, the first thing when I see this component comes to my mind is how can I create this? Let's say there are 4 divisions and there are 4 colors. How can I create? The first thing that comes to my mind is I can add 4 divs, and every div can have its own background color. But the important thing to note here is this is exactly not that. This is actually a linear gradient. Okay, I could have added 4 divs and each div can have its own background, but this is not that. This is actually a linear gradient. Why? Because wherever we can, we want to remove the extra DOM nodes. Okay, the idea here is to remove the extra DOM nodes. Why? Because see, if you have less number of DOM nodes, that it automatically means, you know, less load on layout and painting. Okay, still not painting, but yeah, less load on the layout. Okay, and if I have to show you if I inspect it and show you the gradient, this is actually not a, just give me a second. See, this color that you see, they are actually not divs placed in flex. Okay, we could have done that, we could have placed them in flex, we could have applied background color to each div, but instead the better idea here is to add a linear gradient because we are saving on the DOM nodes. Okay, we are saving on the DOM nodes here. Secondly, an interesting thing to note here is when I move the slider, or let's say when I move the slider, technically when it is in the hands of the user can move the slider, you know, you don't know at what pace he's going to move the sliders. Okay, so instead of changing the state in this, okay, we are not changing the state here, by the way, using set state to get these values. What we are doing here is we are utilizing, see, we are changing the state, but just not through set state. What we are utilizing is refs. We are utilizing refs here. Okay, now as and when you move this through the position of the slider, we do a bit of calculation here and there, and then we calculate what should be the value when, let's say you are not moving the mouse anymore. Okay, or let's say when the mouse down event is fired, we calculate the value. Then what happens is, maybe I'll show you the tooltip. I will force state a hover on this. Yes, so just like I said, we are not changing the state here because technically the user can move it at any pace, and it would not be a good idea to change the state on every, let's say on every movement of the slider. Now instead what we are doing we are calculating the values on the fly, we are storing it in the refs, which is passed on to the child component, which are these sliders. Okay, now if you have a look at the tooltip, now the thing here to notice, tooltip is also not a DOM node. Tooltip is also here a pseudo element. So in kind of way we are saving on the DOM nodes here also. Okay, so it is actually a pseudo selector. This is also not a DOM node. Now if you see the content, right, if you notice the content here, this one, the content says attribute data tooltip label. So what we are doing is we are calculating the values on the fly. We are calculating from the position of the slider, we are calculating the values on the fly, setting it on the ref, and then setting it on the ref and also on the attribute of the HTML element. Then what happens is, in style components there is a way in which you can pick those attributes. For example, this is the attribute. Okay, this is exactly the value that you see on the tooltip. This is the attribute. That's exactly the value that you see on the tooltip, and in style components there is actually a way where you can read all these attributes. So what we are doing is, instead of updating the state through set state, we are updating the values on the fly, and for rendering them we are making use of this attribute which we have set on the fly. Okay, so the idea here, and also just like I mentioned, we are not adding any DOM nodes. This is just the pseudo selector, okay, before and after. So the idea, and let's say the conclusion here is that even if we follow the same ground rules, we have the tooling at hand, and if we follow the same ground rules, or maybe remove the load from the, let's say, the renderer process, and delegate it wherever possible, the if not 60 fps, let's say very close to 60 fps, the UI, the UI components can be performant. Okay, because the tooling is available. See, everything is available then and there. Okay, we just have to follow the same ground rules, and maybe even if you're delegating a lot of work on JavaScript, we should first see if that can be done alone through CSS. Okay, so these things we can keep in mind, and if you follow these things, components can be visually, complex elements can be very performant. Yeah, so thank you. That was my time, and I would love to connect with you all. Thank you.
Any questions, guys? Awesome. Thanks, Pulkit. Okay, next is Srinivas Gowda, and he is going to talk to us about using microfrontends with SSR.
Hi guys. Just give me 1 minute here. So yeah, thank you for joining on a Saturday. I know it's rather long evening actually. And my name is Srinivas. I work with a company called Prequin, and I work as a front-end engineer, obviously, because why would I be at a React.js conference otherwise? And yeah, so I want to talk a bit about something I've been experimenting with for a while now. A couple of issues, things that I feel that could have been better, right? So server-side rendering with microfrontends, that's a mouthful. Now, basically, I just want to cover a few things. Microfrontends in general, microfrontends with server-side rendering, the problems that microfrontends solve, require tech stacks and tooling that comes along with it, and basically the composition of microfrontends, right? So it could be server-side, it could be client-side mostly, and inter-micro app communications. This is basically what I want to cover today. So why use Microfrontends in the first place, right? Like all this tooling and, there's Next.js, all of that good stuff. But when you have a team of 200 plus engineers, you know how crazy it gets on a Friday night. When you want to leave to a pub and your boss is like, code फट गया, right? तो मैं क्या करूँ? तेरा code था. So you're like, okay, I'll do a hotfix, and then you end up working in the hotfix, and finally you get to the pub, and you're not so happy about it. So if you were and also the fact that there's a code freeze, you have to merge in the release branch and all of that stuff. So that's the reason microfrontends are a good thing. It does come with a bit of effort, but it's worth it. So why use microfrontends? Obviously because we have multiple teams working independently. We don't want to rely on one team to push their code and then you write on top of it. It's more maintainable and reduced code. Depends, but mostly that is the case. Independence and autonomy, you don't have to talk to anybody that you will be changing a part of code which they maintain for some reason. So it is your code and it resides in probably a poly repo, or you have a mono repository with learner. Ideally, those are the two cases, right? So scalability and performance, if done correctly, it would be a great benefit. Just microfrontends, not even with SSR. And the possibility of using different technologies. It is crazy to think about using Svelte with React, but it is possible. Once in a while, we do all indulge in the occasional Svelte on a Saturday, even though we do work on React.js from Monday to Friday. We've all been there. So client-side composition is quite simple. You have a bunch of JavaScript and HTML, which kind of gets bundled on the client side. Nothing too fancy. This is what we've kind of been dealing with from day one since we've picked up React.js, right? Then comes a server-side composition. It's an assembled page. So we have different teams working on different parts of the page. We can call them fragments here. And these fragments basically get composed into a single page, but not on the client side, but rather on the server side, right? I'm talking about server-side composition. The server-side rendering is slightly different than this. So server-side composition will take care of building the page, but there's no guarantee that it's going to build the React.js application into HTML for you, right? That you have to rehydrate on your own. So you'd be like, why all this stuff? Why do I have to kind of go through all this? Sometimes you might feel, right? And to kind of understand, break it down into simple pieces. Every server-side micro-frontend that is out there, just a few, but I'll name them in a bit, but it all comes down to these components. We have a routing engine, we have a layout service, we have fragments, right, which are individual components which are going to make up the page at some point. And then you have backend API calls, which could be, a part of the fragment itself. Right. So this is basically it. You have a routing engine, you have a layout service, you have fragments. Layout service, you can think of it like pages, and fragments are nothing but your individual components that make up the page. And routing service literally routes what URL should be mapped to which layout service, and then vice versa. Right. So you might wonder why not Next.js. It's such a beautiful framework, but there is no SSR support, sadly. They use something called as module federation, and this is the plight right now. What we have, we don't have support for having proper server-side rendering support with microfrontends. So if you are a big company, you have a lot of engineers working, probably that's the reason your engineering manager is like, I don't want to look at Next.js right now, because it just won't scale for you, right? And it's paid. It's $100 a month. It is hard making a living out of open source, but it is still not time tested. It says it's a proprietary code, right? And yeah, so that is the plight with Next.js. So there's a lot of abstraction that goes along, right? With all the tooling we have, every software, like Webpack has so much of abstraction. I don't think I've ever open the Webpack file in a couple of months now, right? You usually don't go there. It's something that you kind of do and you just forget about it, and you just expect it to work. The only time you wanted to look at it is when there's a Webpack upgrade or something. So abstractions are good, but too much of abstraction can kind of make things not so easy to kind of handle, right? So I was looking for a solution which had all of these things, which had support for microfrontends with server-side rendering, and I kind of looked at a couple of options, and what I concluded was there's this company called Namecheap. Might have heard about them. So they have open sourced a solution called Isomorphic Layout Composer. Quite a mouthful again, but what it is a bunch of tooling softwares, not written in Node mostly, and it's also uses single SPA. If you remember, microfrontends were based on single SPA as original as it is. And TailorX, I'll come to that. So TailorX is our layout service. So it is based off another open source solution that is no longer maintained for some reason from a company called Zolando. It was originally called Tailor. So Namecheap picked that up, saw value in it, and they have been maintaining it, but not. So there are a few bugs, right? And they give you server-side rendering support out of the box. They have a built-in registry to add new apps, pages, change configs, templates in just a few clicks, and possibility of using different technologies. Obviously, you can use Vue, Svelte, and React together in a microfrontend. The stack would really not care. Like, obviously, you would say that how would I kind of share my state? If you have a microfrontend and if you want to share your state, then you should not be using microfrontends, right? You might want to talk to the microfrontend layouts, right? You want to talk to another microfrontend. So originally, this was a problem, and then they said, okay, why are we looking at? We have the event listeners. Just emit the events and filter the events out, and that's as easy as that, right? If you wanted to enter microfrontend communication for some reason. TailorX, as I said, is a layout service. It uses streams. So streams are much better. So you don't have to wait for a particular page to kind of load up, and then it kind of gets to the browser. So it does this cool thing called streams, but it's not something very fancy. Node.js has this, so if you want to build something like this, you could build it on your own using an Express.js server. So streaming composition. So if you look at this diagram here, you see that there's an assembly that happens after all the components are in, then the final thing goes out. Then you have partial rendering, where you send out when, and then whatever comes in, you just send it to the browser. And sometimes what happens with this case is some stuff don't really load on the page, and the user's not really happy about it. Then comes the streaming response. Think of this like your Netflix. You do have a when you watch a video, you get what you need initially, and then the rest of the thing buffers, right? Something on those lines. And then they use single SPA router and adapters, ILC. So single SPA is a routing engine. It does one thing and only one thing, which is routing. And as important as it is, it also gives us the support to hydrate your layout service, right? So ILC basically has these adapters that kind of hooks into single SPA as a plugin, and each language has its own adapter. So right now I think the most active ones are Vue and React. So a worthy mention would be PodiumLib. Quite well maintained, really well documented. I'll get to this in a bit. The reason I say this is a good take on this is because most of the things what Zolando built with a project called Mosaic 9. I'll get to all the softwares in a bit. Mosaic 9. So they built on those architectures, right? So PodiumLib is worth a check. And the possibilities with doing microfrontends on with SSR is that we sometimes kind of forget that we have all this computing power that's sitting in AWS, and why do we kind of just not use it? And AWS Edge, Lambda Edge, just like your CDN, can have functions that get invoked closest point to your user's request. So obviously, if your APIs are quick, because with server side, you would expect your JSON or your API calls to bundle together and then be sent to the client side. So that's a big win. So PodiumLib has an easy server-side composition for Microfrontends. But yes, PodiumLib does not do one thing, which is hydrating. So it does not take care of your React application being hydrated. It does not take care of your React application being stringified and converted to HTML. That you have to do on your own, which is not too difficult. But yes, I have been facing some issues there. But that's mostly it. Let me get to some of the softwares I was talking about. If I can just share my screen again. And I do have a demo on how easy it is to create a microfrontend. Sorry, how easy it is to create a React server-side render. I don't know what I did.
Yeah.
Did I close it? No. Sorry guys. Just dumbed out there for a bit.
That is the
Closed it.
video closed. Okay.
Yeah. So while this sets up, also there's an issue with, how we treat some of the libraries on GitHub. If it's older than a year, we judge the library like anything. We would be like, hey, he doesn't maintain this library, why not just look for another one? Even though that library has been good all those years, instead of actually posting an issue or trying to see if we can fix it or do a simple upgrade on libraries, because maintainers don't get paid to do this mostly. And that's a case with some of the best softwares I've seen. Like Mosaic 9 was a brilliant software stack. One second. Yeah. So Mosaic project was a brilliant software stack. So Taylor X that I just spoke about, which is a part of ILC from Namecheap, is actually originally picked up from here. And it's not been maintained for a while now, for about 4 years. But Zolando still uses it for their website. And if you guys have not about Zolando, Zolando's like Myntra, but they're like really huge in Europe. They have they've probably passed 2 billion revenue, so they're huge. And the tech stacks look something like this. Like I said, it's basically a routing engine connected to a layout service, and then you have your fragments. It's as simple as that. And if you have time in your company, like I was just talking to Pulkit, and he told me that one of his seniors, about 2 years ago, he wrote an entire layout service that kind of hydrates and kind of provides you with the server-side rendering. Right? So it is possible. The problem with JavaScript is you need to do a lot of tooling. You're not comfortable with doing tooling because most of the tooling that you do in Node.js is not performant. We don't look for alternatives like Go, right, which is easily shippable and stuff. We're just too comfortable with JavaScript, right? And have you guys used? How many of you used ESBuild? Snowpack ESBuild. Brilliant, right? The performance is crazy. It's, I don't know what X good, but I hate Webpack. Right? Come on, we've all been there where you've been waiting for your test cases to complete. If you have a huge legacy code base, guys, trust me, it's going to drive you crazy. So all those things, we don't do a lot of tooling, and this beautiful project got kind of put in a back seat. If you see, Innkeeper is not even being maintained. It's been 6 years. There have been 5 issues. Skipper somehow kind of maintained to an extent because they use it internally for the Skipper sort of like your reverse proxy engine. You're like your Nginx, right? It's written in Go and it's very performant. You can use it for like all kinds of stuff, ingress controllers and things. ILC, this is the one I was talking about. Quite good. Looks. I do have a bit of issues with setting up the demo. It uses a slightly older version of Node, but it is quite good compared to everything out there. Right? It promises SSR out of the box. It has single SPA and it uses Taylor X. So they call it isomorphic layout composer. So they have single SPA, Taylor X, and they have parcel plugins, app wrappers, and all kinds of good stuff, right? So like I said, same thing with this is you have a routing engine, you have a layout service, you have fragments, and that's mostly it, right? And Taylor X is a separate project on its own. Even this project is not that well maintained. It's been about 3 years since you saw last commit, but it is what it is, right? Not many updates go there. And yeah, some of these issues with tooling, right, is mostly because we don't take the effort to kind of build something. We always look for, hey, was React going to ship something for us, or is because React is, we like React because there's less abstraction. Come on, because it's just a library. We like to glue things together, and even though it's it never breaks. Like I've seen guys work on React.js code base as old as 7 years. It doesn't break, right? Angular JS to Angular, you know how horrible that was, right? It literally broke 98% of your code base. Nobody really knew what was happening. That was a lot of loss for companies. So yeah, Next.js is quite promising. There's also another alternative called Remix, which is too good to believe. It almost feels like magic if anybody's kind of looked through their website. It literally feels like magic. I don't even know what's happening behind. Too much of abstraction. But yes, like somebody said, it's not a silver bullet, Next.js or Remix or anything for that stuff. So you basically end up taking something which is out there, which works for you, and start tooling on top of it and maintain it for your company or for personal projects, right? And streaming composition is a great idea. Like, that kind of adds a lot of value. I don't even know why I'm showing you this. So yeah, so streaming composition, look into that. I do have a demo, but maybe I'll just share it on the GitHub repo. It's basically just a Express.js server talking to a React.js application, hydrating it. Nothing fancy there. It's as easy as that. It's so DOM server. Basically, React documentation says that if you want to do server-side rendering, you use a DOM server, do stringify, and then do stringify on the server side, and then on the client side, you do hydrate, right? And that's mostly it. It takes you hardly a couple of lines of code to put it together, but yes, there is a lot of tooling on top of that. It is simple to put together a simple application like this, but it does take effort to kind of put a tooling like Taylor and Nginx. Like server-side rendering is not a new thing actually to the. So BigPipe, if anyone's heard about BigPipe that Facebook launched in 2009, sort of did something of that sort, right? And Mosaic 9, it's about 6 years old, started around the open source in 2016. So people do it with Java, server-side rendering is done in Node.js and all kinds of languages. It's just that there's a lot of tooling that needs to be done, and also the fact that we don't like to deal with DevOps, right? Nobody wants to write a CI/CD pipeline, at least not most of my colleagues who are front-end engineers. But I think we should take effort in writing some CI/CD pipelines. Be comfortable with AWS because finally it does reside in AWS. That's where your real performance does come from, right? We do all of this stuff on browser, but we forget that if your APIs are not loading on time, it's still going to slow your site down, right? And yeah, that's mostly it. Any questions? Yeah.
Hi,
Hi.
good evening.
Good evening.
So basically, when we do SSR, the thing is, when the code is sent to the client side, we actually do hydration, right?
Yes.
So in one of the articles that I read, it basically said that hydration is an overhead because when we do SSR, the event listeners are binded to
Yes.
the HTML and then sent. But again, the same thing is done again on the client side as well.
That is correct.
Yeah.
And there's no other way around it because
Yeah,
you
so-
have to have event listeners on top. But what Microfrontends does help you is with not the event listeners, that's inevitable because you have to have those. And if you have a proper lifecycle for these event listeners, it's not going to be an overhead. That's always the case, right? Like we forget to unsubscribe from so many events, and it eventually, like a simple debounce on an input box or I don't know, screen resize. If we really don't unsubscribe, we forget sometimes, right? If you don't have a proper utility function which kind of does these things for you, it is going to be overhead. But where Microfrontends with SSR really gives you a boost is when you're having this huge chunk of JSON that you want to fetch, right? You don't want your client side to take care of that. You rather do it on the server side. Like what Next.js does is it allows you to take this chunk of JSON, right, from your server or GraphQL, whatever, and push that to the browser along with the page. So the composition is really powerful because you and the layout painting is powerful. Everything falls in place because you have so many things happening parallelly in the server, but here it's not so performant because you're running on literally a single threads, right? Unless and until you really you can't even use web workers for a lot of things, right? So it's always good to use for these conditions. But yes, there is an overhead, but there's always a workaround.
Basically from what I read, there is this something called resumability, basically where we serialize these event listeners in the server and do it. So I was wondering if it's possible to use resumability with SSR.
Well, I don't think there's currently anything of that sort, but I do remember that there was a project called Lit, if you remember. These were web components from Google. They were called Lit components. So they do have something of that sort. But for some reason that project did not kick off. There are a few companies are using it, but that kind of microcontrol, if you want, you will have to tool it on your own. But I'm not really sure if there's anything out there which is like ready.
Thank you.
Any other questions, guys? Okay. Thank you, guys.
Thank you, Srinivas, for the insightful talk. The next one is Subendra Kumar Sharma. He'll be talking about how to use and plug in LimberGridView.
I'm audible, right? Yeah, hi. Many of you might have never heard of this library before, which I wrote, LimberGridView. So basically what it is it's a resizable, movable grid layout for the end user. And it is auto-arranging. It uses computational geometry to do all its computation regarding arrangement or whatever, anything regarding arrangements. Yeah, so how is it different from other existing libraries? So what it does is it breaks the constraints on fixed layouts. So the end user basically has the freedom to choose whatever size of items which he wants to see on the screen. So that's the main goal of this library, and it was built out of pure curiosity rather than just business needs. Yeah, and it has some constraints, like for example, it has some minimum height or minimum width constraints, and one of the constraints is that the height can't be more than the viewport, and the width also can't be more than the viewport. Viewport in the sense like the parent element. So this talk will consist of demos. I'll do some coding to plug it in, and we'll have some Q&A. And yeah, so it has an intelligent algorithm which selectively selects item to arrange. By which what I mean is, let's say you have 100 elements, right? So you move an item from one place to another place. So to do any geometric calculation, it is very computationally intensive, right? So what it does is in a single pass, it will figure out which all items it needs to work on. So after figuring out, it probably selects like 10 or 15 items it has to work on, and it works on those items, calculates free spaces, and figure out where to put items. And it has been tested on like 1,000 to 2,000 elements. Items on screen. You can have 1,000 to 2,000 items, and the time complexity on your move operation or your resize operation won't differ because of the of the intelligent algorithm which I told you about, the selective process. Coming to its time complexity, the best case is 1 to 10 milliseconds, depending upon scenarios, and average case is 10 to 100 milliseconds, and worst case scenarios for items which are really far apart, it's 100 to 300 milliseconds, and I'm currently working on optimizing it as well. Basically, the optimization was done. It still needs to be done, but currently I'm focused on the UI and usability aspects currently. And for tablets, basically mobile devices, it's slightly slower. Yeah, and also when you re-render when you perform any operations, right? So it has to do some re-rendering, right, on the items. So when you resize, you have to resize the contents inside it, right? Or when you delete, you have to make some adjustments. Or when you move, you have to make some adjustments. So it re-renders only the items that are affected. So it minimizes re-rendering also. And yeah, so so you can store the output data, that is the data for the sizes of various items in local storage. Like, you don't need to store it on database, right? So let's say suppose the user logs out, right? So in that case, if you provide an array with empty objects, it will just
render squares of equal sizes. So basically, you don't have to store any of these user data on your database. And the output is by default scaled to 1920 pixel by 1080 pixel. So this is like, say for example, you have a 720p screen, you're using it on that, and when you get the output, it scales to the default value, that is 1920 by 1080. So coming down to features, right? Yeah, so as I said, it has movable and resizable grids. It has built-in intersection observer. So whenever you scroll, it doesn't render like, let's say the user has 100 items. It doesn't render all 100 items. It's kind of like a sliding window kind of thing. So only what the user is trying to see, it will render those items. It has built-in resize observer. So if the user resizes the window, it will scale automatically. It has built-in undo redo function. It has touch support for tablets of any size. So I'll get to this point. One interesting thing is, what I've found is there are two types of touch screens. So mostly for small screen, if you touch hold on the screen, right, it will fixate to one particular point. But for other type of touchscreen devices which are larger in size, when you touch hold, it does not fixate to a particular point. It picks up minute variations. So it has support for that also. It supports mobile view. So when let's say the user resizes the window, it automatically goes into the mobile view. It has plugins for applications. It is built using vanilla JavaScript. So it has plugins. Basically, it's a callback function where you supply whatever needs to be rendered, and it's one of its main principles is to minimize computation. Yeah, coming to user interface. As I said, the user can define his or her layout. Their design is their size. There are no constraints apart from which I mentioned earlier. They can swap items. They can even push items when they try to resize or move. They can swap multiple items when they want to move. We have latching in corners and edges. I'll get to this when I'm doing the demo. You can delete empty space when you have a narrow strip of space which you want to get rid of. You can basically draw a rectangle to add items on screen. Users can try different things and they can get used to it, and they can have their own set of things, and it's fast and optimized. Yeah. Yeah, so for developers, most features are built in. It is plug and play. It has the developer basically doesn't need to write so much code to plug it in. Customizable CSS, you can customize the way it looks. You can import grid data, and this is basically written in vanilla JavaScript, so you can plug it in any framework you like. Yeah, so some problems which we have right now is floating point errors. So due to this problem, we can't go to a stable build right now. So based on interest from people, it can be accelerated to have a stable build in 6 months, but I'm going slow right now. So what undesired outcomes means is when you try to move certain items or when you try to resize certain items, it moves certain items which is not supposed to move. Yeah, and empty space. So when you're scrolling and you have a huge empty space, the scrolling breaks. So this is a minor bug, and we have some scroll issues in iOS. This is also a minor bug, and sometimes when you move items from far away, there's a zombie item, which means it's rendered but you can't do anything with it. It's also a minor issue. The main issue is the floating point errors, which I'm currently working on. Yeah. Yeah. So moving on to demo, resize. Sorry. Yeah. So you can resize your items like this anywhere on the screen. It will latch onto the edges or corners of any item. So I want to latch it in this corner. It will just latch it. Pushing. So let's say I made some mistake, and I just want this item which I resized, I just want to push it aside. I can do it. Let's say again I want to push it this side. Okay, yeah. I can push any items. Yeah. Yeah, move with latch. Yeah. So when I try to move any item, it will try to swap the first time. Oh, my fingers are shaking, sorry. So this is basically latching on to the bottom corner. So basically this helps in maintaining symmetry in your apps. So yeah, this is basically swapping items. Yeah, so I want to latch it here on the edge. I can latch it at the edge or on the corners or on the edges. Yeah, pushing while resizing. So if I want to push these two items down, if I resize it, it will push these items down. Yeah, so I see it will even push these items down. Or oh, sorry, it was while move, right? Sorry. So I'll disable the latch feature and I'm moving it down. So it will move the items down. Removing an item. So this when I click on the remove button over here, basically it's calling remove item function, and it will remove this particular item, and you can update your data based on the removal. Auto scroll. So one interesting thing is in some touchpad, right? When you tap hold any item in some touchpad, you can use your other finger to scroll, but in some cases, particularly in Windows laptops, this is not the case. It will simply trigger a mouse up event. So in this case, what it provides is you can basically move your mouse near the top of the screen, it will scroll. Bottom, it will scroll. So this is one of the feature. Yeah. Add by dragging. So basically I can choose this add by dragging feature. It's just setting a flag in the library. You just call a function for that, and I draw a rectangle, and the feature, the item is registered and it's added, and this is plugged in. Basically this is the developer's code, and when you click on add, you click on add item, you trigger your own code to render stuff. You basically trigger register some callbacks that will put the elements in inside the item. Delete free space. So what I'm going to do is I'll just remove some items. So yeah, cut space tool. Yeah, so when I choose this tool and draw a rectangle, basically it will just cut the free space. It shouldn't have any items in between. So let's say, for example, there was this item. Sorry. There was this item here, and I try to cut space. This will not work because there is already an item here. So in order for this to work, it has to have a clean area, and you can cut the free space and everything will move up. Yeah, intersection observer. So yeah, so I have a long list. So basically, as you can see, when I'm scrolling right, you can see that it's re-rendering everything, and you can basically figure out that at a particular point of time, only the item which is being viewed by the user is being rendered. Resize observer. Yeah. So yeah. So basically, when I resize it, the width was less, so it went to mobile view. If I resize it again, it's configured to a desktop layout for this width. So you can see your layout being rendered. Yeah, yeah. So that's that. Undo, redo. Yeah. So basically, it has built-in undo redo feature so that the developers don't need to program it. If I do any operation like moving or resizing, you have this undo redo feature, which is probably very handy. Yeah. Change margin. Yeah, so the change margin, you can dynamically change margin, but this feature hasn't been released as a beta version. It's a work in progress. I'll show you. It couldn't be released for this demo because we had some issue with I had some issue with floating point numbers. So I click on this button. I can increase margin dynamically. And yeah, I can decrease it all the way down to 0. So this is my dev environment. Like it's not even released. It just has a branch on GitHub. Yeah, and this I think I forgot to plug it in. I think it's stuck. It's not a really high powered laptop, so basically the undo redo should work for change margin also. Yeah. So now I'll just do some light arrangement so you just get the gist of what it can do. Yeah, so Yeah, so that's a small demo. So we'll move on to code right now. Um, so first of all, we have EL, which is basically the element. Oh yeah, first I will go through your Redux store. So this is view. This is basically to toggle between default and customized view. This is default view. By default, you don't have a resize tool on the left side. You can add a flag and you can get that. By default, you have this ear-like thing by which you can resize. Basically, this is vanilla. I didn't do any CSS changes. And this is the customized view where I made several changes. Yeah, so this is for that. Latch is basically to latch or not to latch. So if I unselect this and if I go near any item, it won't latch. But if I check this, I try to latch, it will latch onto the edge and it will basically have symmetry between items. Dex interaction mode, it's basically this add item by dragging or cut space, this option. Position data is your array of coordinates, basically the top left corner and height and width, or it can be top left corner and the bottom right corner, array of those, any of those. And basically this is your Redux. So main thing is we have change view action, change latch action, change dex interaction mode action, and set position data. So we'll focus on those. Now moving on to how we can plug it in. I have a use effect, and on render I'll try to render my view on this element. So first I have I'm not good with naming functions, so you probably want to excuse me for that. So you have this function. So basically what it does is, so in your customized view, I was able to tap hold on the top section where the heading is written, and I could engage the move operation. So for this, I have this function callback registered, and here I will am I running out of time? Like, it will take some time, so.
It's better to give a quick walkthrough.
Oh.
Give the code base, link to the code, if you can go through.
Oh, okay, sure. Yeah. Yeah. So we have various callbacks. So this here, basically, I'm checking whether the place where the user clicked, right, whether it has this particular classes or not. If it has, then you can trigger this the move operation. Render complete. So in render complete, basically I'm not doing anything with it because it's not a complex application, it's just a demo application. So it's a function where you can do some of your activities after the rendering is complete. Render content is a main thing. So here I'm passing a JSX component. So as I said, this is a vanilla JavaScript library, right? So it does not understand this thing. So for that we have a render plugin and remove plugin. So here I have React DOM render. So the render data is basically whatever you passed here. Here you can pass a node or a string. it will render it. If you pass any other thing, um, it will pass it back to your render plugin, and you can have some framework like React and render your item, and remove plugin to remove unmount your element. This is basically when you want to remove any item. And on various operations like resize complete, move complete, add complete, you want to save your position data on your Redux store, because if you move out of your current page and come back in, you won't have your data. So if you save it, you'll have the data. Or for example, say the electricity event. So you have this callbacks, you can put it on your Redux store and your local storage, so that when user comes back, it will be as in the latest form. Yeah, other things, we have some constants. Yeah, so show bottom left resize guide. So basically, if this is true, you'll have the resize guide on your left bottom side. Yeah, so that is a quick walkthrough. And one more thing. I think I don't have time for this thing. Okay, thanks. Yeah, so so this is, you can access this library through my website, limber.in, limber.in. There you'll find links to the GitHub repo and the example code. You can install it through npm. The instructions are there in the GitHub repo. And yeah, if you want to get it for your application, it's currently in beta version. So it will take some time. If you register, it will probably get fast tracked, and you might probably have a stable release in 6 months, probably. Yeah, so that is how you can get it. It's licensed under GNU GPL version 3. So if you want to use it, you have to get a license from me. Yeah, so it's free software. You probably want to learn more about free software. It's open source, but it protects all the 4 freedoms that one should have in a software. Yeah. And yeah, that is it. Thanks.
Thank you guys. Thanks for being a part of this meetup, and we can continue networking. The coffee is still open, and I hope you guys enjoyed and got something to learn today. So over to Kiran.
Yeah, thanks everyone for joining, and all the 5 talks were amazing today. Learned a lot of in-depth stuff. Need to review it again. I hope you all learned a lot, and got to meet new people during the break. Yeah, we'll keep doing these events every month. So keep an eye on our meetup page, meetup.com. React.js Bangalore. So probably next month we'll be having on October 15th. And if you want to speak in our upcoming meetups, right? Whenever we announce an event, there will be a link. You can propose talks there, and you can be the next meetup speakers. Yeah, looking forward to it. Thank you. Yeah, the venue will be open for like 10 more minutes, I guess. So we can go outside and network a little bit, and then meet again in the next event.